In this question, we're going to have to build up to a really tricky binomial expansion involving two different brackets. However, in part A and B, to get there, we need to do 1 minus 2x to the power of 6 and then 2 plus x to the power of 7. So let's start off with those. So I'm going to do 1 minus 2x to the power of 6. And writing that out as a binomial expansion, we are going to get 6 choose 0 times 1 to the power of 6 times minus 2x to the power of 0. And then the next term will be 6 choose 1, 1 to the power of 5, and then minus 2x to the power of 1. The next term we'll get 6 choose 2, 1 to the power of 4, and then minus 2x to the power of 2. And we'll squeeze the last term in. We'll get 6 choose 3, 1 to the power of 3, minus 2x to the power of 3, dot, dot, dot. So I'm actually going to leave it there because in our question, we are always just worried about the first 4 terms in ascending powers of x. So we're just doing those ones. Let's simplify this afterwards then. So 6 choose 0 is 1, 1 to the power of 6 is just 1, and anything to the power of 0 is 1. So we'll just have 1 here. Our next term, 6 choose 1 is just 6. The power of 1s we can always ignore. And then we've just got minus 2x. 6 choose 2, I will do on the calculator. So 6 choose 2 equals 15. 1 we will just ignore. And minus 2x squared will give us 4x squared, positive 4x squared. Next we've got 6 choose 3, which is 20. And our minus 2x cubed will give us minus 8x cubed. I'm still going to put dot, dot, dot. Okay, last step of simplifying. We've got 1 minus 12x, that's this x term. We've got plus 60x squared. And then we've got minus 20 times 8, so minus 160 x cubed, dot, dot, dot. Those are the first four terms of our first binomial expansion. So I'll now change colours for our second one. For part B, we're doing the same thing for 2 plus x to the power of 7. So again, let's have a look at that. So 2 plus x to the power of 7. This time it's always going to be 7 choose something. So we'll have 7 choose 0, 2 to the power of 7, x to the power of 0. Then we'll get 7 choose 1, 2 to the power of 6, x to the power of 1. 7 choose 2, 2 to the power of 5, x to the power of 2. And then 7 choose 3, 2 to the power of 4, x to the power of 3, dot, dot, dot. Just about squeeze it in on one line. On to our next line. So 7 choose 0 will just be 1. 2 to the power of 7 is 128. So we'll just do 1 times 128. 7 choose 1 is just 7. 2 to the power of 6 is 64. And then we've just got an x. 7 choose 2, I'll do on my calculator, is 21. So we've got 21, 2 to the power of 5 is 32, and then we've got an x squared. And 7 choose 3 is 35. So we've got 35 times 2 to the power of 4 is 16, times an x cubed. So again, we can simplify. We've got 128 plus 7 times 64 is 448. Then we've got 21 times 32, which is 672 for our x squareds. And our last one, we've got 35 times 16, which is 560 for our x cubed. Okay, we have both then of our binomial expansions that we wanted in this question. Okay, so for part C of this question, we actually have both of our binomial expansions so far. So 1 minus 12x plus 60x squared minus 160x cubed. And then 128 plus 448x plus 672x squared plus 560x cubed. We've now got both of our binomial expansions, and we want to use these, that's why it says hence, to work out the coefficient of x squared when we expand these two multiplied together. So my first step then is going to be writing them actually multiplied together. Let's have a look at it. So we need to do 1 minus 12x plus 60x squared minus 160x cubed. I'm still going to put ... in my brackets, but I can ignore anything higher because we've only worried about the first 4 terms. And if I ever want to get an x squared, I don't need to worry about x cubes and beyond. In my other brackets, I'm going to write 128 plus 448x plus 672x squared plus 560x cubed. Okay, they're my 2 brackets. What I'm interested in is when I multiply all of this together, how many x squareds are going to come out the other side. And let's think about how we actually get x squareds from these. Well, there's only 2 ways you can get an x squared. You can either have a number, like 1, times by an x squared in the other bracket, or you could have an x times by another x to get an x squared. If we consider all of these possibilities then, there's one way we could get it from here. We could have 1 times 672x squared. That's one way. So let's write that down. We could have 1 times 672x squared. That would give us an x squared term. There's actually another symmetrical way like that though. We could have, if I switch colour, the other way round from these brackets, we could have 60x squared times by 128. That also works. So let's add in, we could have 60x squared times 128. And the third possible way that this could work is we could take the x from either bracket. So we could have, and be really careful here, a minus 12x and a plus 448x. So if we do add minus 12x times 448x, this will also give us an x squared term at the end. I do need my calculator for this. So we've got for our x squareds, we've got 672 plus 60 times 128, which is 7,680. And lastly, we've got minus 12 times 448. So that's minus 5,376x squared. And actually this question, the x squareds at the end aren't going to do anything. We're just worried about the coefficient, that's the number in front. If we work this out then, we're going to do 672 plus 7,680, take away 5,376. That leaves us with 2,976x squared. So the coefficient is 2,976 in this question.
If you made it this far in the video, well done. On the screen at the moment is a similar follow-up problem to what you just saw. This would be really good to check if you've understood what was in the video. So have a go, and can you post your answer down in the comments below?